November 22nd, 1922, Gosport, Indiana. A child was born into a world that would soon be consumed by economic collapse and global war. Eugene Morrison Stoner entered life with nothing but his name. In a small farming town where most families struggled through the Great Depression, nobody could have predicted that this boy, who would never attend college, who would spend his early years installing aircraft parts in California factories, would one day design the most controversial and widely used military rifle in modern history. The pencil moved across paper as the young machinist sketched modifications to weapons he had never been formally trained to build. Working late nights in his Long Beach barrage after shifts at Vega Aircraft Company, Stoner was trying to solve a problem that had frustrated military designers for decades. How could you create a rifle light enough for soldiers to carry through jungles and mountains, powerful enough to stop an enemy at 500 yards, yet reliable enough to function in the harshest conditions on Earth? According to every expert in the firearms industry, according to the United States Army Ordnance Corps, according to tradition stretching back to the American Civil War, the answer was simple. You could not. A truly lightweight automatic rifle was impossible. The physics did not allow it. The materials did not exist. Anyone who claimed otherwise was either a fool or a fraud. Stoner was neither. He was simply willing to question assumptions that everyone else accepted as truth. And that willingness would eventually arm millions of soldiers, reshape modern infantry tactics, and spark debates that continue to this day. The year was 1939. Eugene Stoner had just graduated from Long Beach Polytechnic High School. College was not an option. The Depression had destroyed his family's savings, leaving no money for university tuition. While his wealthier classmates headed to Stanford and Berkeley, the young man walked into Vega Aircraft Company and asked for work. They hired him to install armament on training aircraft. The job required precision, attention to detail, understanding of mechanical systems. It also provided something invaluable: access to aircraft-grade aluminum, a material most gun makers had never considered using for firearms. For generations, rifle makers had relied on wood and steel, heavy, dense, traditional materials that could withstand the explosive forces of gunpowder and the shock of recoil. The young engineer looked at these materials and saw limitations. Steel was strong, but heavy. Wood absorbed moisture and warped. Both added unnecessary weight to weapons that soldiers had to carry for miles. But aluminum, the lightweight metal used in aircraft construction, offered different properties. It was lighter than steel, resistant to corrosion, and when properly engineered, strong enough to handle the stresses of rifle operation. The problem was that nobody had successfully built a combat rifle from aluminum. Every attempt had failed. Stoner filed that observation away. He would return to it later. December 7th, 1941. Pearl Harbor. Like millions of young Americans, the 19-year-old enlisted in the military. He joined the United States Marine Corps, specializing in aviation ordnance. The Corps sent him to the South Pacific and northern China, where he spent his war maintaining and repairing machine guns, rifles, and automatic weapons. He never saw direct combat, but he saw something equally valuable for a future firearms designer. He saw weapons fail. He watched Marines struggle with the M1 Garand, a superb rifle that was nevertheless too heavy for jungle warfare. He observed the M1918 Browning automatic rifle, powerful, but weighing nearly 20 pounds. He studied the M1941 Johnson rifle and light machine gun, innovative designs that most military planners dismissed as too complex. Every evening after his maintenance duties were complete, the young Marine sketched improvements. He filled notebooks with modifications, alternative gas systems, different bolt designs. His fellow Marines thought he was obsessed. They were correct. By 1943, he had developed two 30-caliber carbine prototypes in his spare time. Neither was complete, but both demonstrated concepts that would later appear in his revolutionary designs. The straight-line stock that channeled recoil backward instead of upward. The simplified gas system that eliminated heavy operating rods. The modular construction that allowed rapid field stripping. These were not random innovations. They were systematic solutions to problems the designer had observed in combat weapons. The war ended in August 1945. The 22-year-old veteran returned to California and immediately sought work in machine shops. He was hired by Whitaker, an aircraft parts manufacturer, starting on the factory floor. Within months, his skill with precision machinery earned him promotion to design engineer. It was here, working with aerospace manufacturing techniques, that he perfected his understanding of how to machine aircraft-grade aluminum to tolerances that would be acceptable for firearms. The knowledge would prove critical. By 1954, nearly a decade had passed working various engineering jobs while continuing to design firearms in his garage. His prototypes had attracted attention from firearms experts, but no manufacturer was willing to invest in production. Then came an opportunity that would change everything. A small company called Armalite, a division of Fairchild Engine and Airplane Corporation, was looking for a chief design engineer. Armalite had been founded specifically to bring modern materials and manufacturing techniques to the firearms industry. They had fewer than a dozen employees. They had no factory. They were essentially a research and development operation, hoping to license their designs to larger manufacturers. It was perfect for the self-taught engineer. He was hired on October 4, 1954, and immediately sought work on his most ambitious project yet. The United States Army had announced in 1955 that they were seeking a replacement for the M1 Garand. The new weapon needed to fire the standard NATO 7.62mm cartridge, the same round used by most Allied nations. It needed to be reliable, accurate, and if possible, lighter than the 9.5-pound Garand. Every major firearms manufacturer in America and Europe submitted designs. Springfield Armory offered the T-44, essentially an updated M1 Garand chambered for the new cartridge. Fabrique Nationale of Belgium submitted their FAL rifle, already in service with several European armies. Both were conventional designs, steel receivers, wooden stocks, gas piston systems proven over decades. Both weighed around 9 pounds. The Armalite submission was designated R10, Armalite Rifle Number 10. It weighed 7.25 pounds. The Army testing officials at Springfield Armory thought there had been a mistake in the specifications. No rifle firing full-power NATO ammunition could weigh that little and still function reliably. They assumed the paperwork was incorrect. Then the rifle arrived for testing in late 1956. The R10 looked unlike any military rifle the testers had ever seen. The stock and handguard were made of fiberglass, reinforced with foam, materials borrowed from aircraft construction. The receiver was forged from 7075 T6 alloy aluminum alloy, the same material used in aircraft structural components. The rifle featured a straight-line design, with the stock aligned directly behind the barrel rather than dropping below it as in traditional rifles. This meant recoil forces pushed straight back into the shooter's shoulder rather than causing the muzzle to climb. The gas system was revolutionary. Instead of using a heavy operating rod like the M1 Garand or a piston system like the FAL, the design routed expanding gases directly from the barrel through a tube to the bolt carrier. This system, commonly called direct impingement, though technically an internal expanding gas system, eliminated nearly 2 pounds of reciprocating metal. The initial testing reports were enthusiastic.